Okay, project is finally starting. We have to make adapter plates to fit on the engine and on the gearbox to be able to put the two together. This is the original. We have to make something similar to this to be able to fit onto the engine that we'd be able to bolt the gearbox to, leaving a space inside for the clutch. We have 3/4 inch thick, this is 775 T651 aluminum. We are going to machine, the reason we can't use this is because the bolt holes are not far enough apart to be able to clear the drum once it's bolted together. So we need something that's going to be bigger. We can bolt to the engine. We're going to have aluminum spacers going between them, cut off at the right length, bolted together, and another plate on the back. That will be this one that will mount to the gearbox, leaving a space in between. That is the plan, that is the project, and now we've got to begin. First thing we got to do is find dead center of this plate. We have to drill a major hole. This hole here has to hold an oil seal for the crankshaft. The back of the crankshaft comes out to the engine. So the first thing to do is mill this hole. To find center, okay, now we've got a straight edge. I'm going to mark from corner to corner. Don't have to go all the way, just to find the center. We go corner to corner. Find center. This will be our center point. So the first thing that we're going to do is going to drill a hole using a hole saw. We're going to start a hole through here using our drill press, and it's going to leave us a little bit of room. You see how that's close but not exact. The reason we don't, this is going to chatter quite a bit, so we're going to have a lot of wasted space and wasted metal. So that when we put it on the lathe, we'll be able to use the lathe to center cut the hole precisely to be able to fit the oil seal back into here, so when it goes on the engine, it'll actually act as the seal. You'll notice that this is only about 3/8 of an inch thick, and the recess here, by the time we go from this place to this place, we are just exactly 3/4 of an inch of this. As long as this plate has to recess to go over the rear bearing that's on the back of the engine, there's a bearing cup, this has to go over that. Give us enough room to put the seal in. We'll let the project begin. Okay, first thing we did, we've marked a center hole, started to drill it with offset, so now I've taken the center punch, and we punched the center mark right here. So now we can drill this. It doesn't have to be exact because whatever we machine is going to be off anyway. So what we're going to do is find the closest point to center, we're going to drill this out, then we're going to true the hole up on the lathe. To get this done, we have to put this in here. We have to find several clamps to be able to clamp this thing down so it can't move. Now let's double check. Make sure the table is level. And that looks very close. Very, very close. Okay. Next. We'll change over to the hole saw. We're going to get this in position. Okay, now that I've got it clamped down properly on both sides, I put this back in and very slowly just kept working this very slowly. It took me about almost a half hour doing it very, very slowly to get all the way through. So now we've cut out the disc, cut out the center hole. We can go ahead and release the discs, the clamps. These clamps off. And we can see we've got a really nice start on the center hole. Now, in order to check it, this plate wasn't exactly 100% square. When I ordered it. Okay, we got our piece, our hole cut out. Now, in order to get onto the vise to make onto the lathe here, in order to make this piece that we want, we actually have to make this fit. If you'll notice, we take this piece out. This will actually turn with clearance, but it's not big enough. So we have to make the other one bigger than this, right? And by being bigger, if we go the full 6 inches to here, then we can actually clear this. This is almost the exact same size, so we want to make this big enough. We've got 3.5 inches from center to touching. So we can make this all the way to that size. Now what I did was I found a piece of plastic that fits in this hole perfectly. And then I took a compass scribe, where did I just put it? Just got it. Took a compass scribe, put it in the hole down to where it fits tight. And I came out and marked a line. Scribe the line all the way around. I don't know if the camera can see that or not. I'll try to reflect it. So there's a disc. Now that is to give me a perfect circle to the edges. But we need it bigger because we need actually to come out a little bit more in order to make the bolt holes in the corners. The 4 bolts have to go in with round dowel that we're going to put through. Put the aluminum round dowel here. This is going to go between the plates. But this is so big that when we put it on the lathe, it won't turn. So even when we get it centered, it won't clear. So we can go 3.5 inches. So what I can do, if this is 3 inches, put this back in, what we can do is we can open this up another 1/4 inch. Another 1/4 inch from that line. Let's go from the point. Put it right on the 2. We can come out another 1/4 inch, which would be 2 1/4. Right to there. We can put our compass in again. Bring this out until it's touching the 2 1/4 mark. And this will be the corners cut there, 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 and there. Now that will give us enough height to be able to turn it on the lathe. It's going to be really close. But we'll be able to turn this so that we can put this into the faceplate in here, because this lathe is so tiny. Now we could go and get a bigger lathe, but we're not going to do that. We're going to use what we've got. So we've got to cut these corners off now. And then we can, once we get this, so it'll fit onto here, we're going to turn out this in order to fit onto the engine. So right now we're going to cut these corners off, and then we'll be back. Alright, this is how we've been cutting the corners off. We've got a small drill bit. We're drawing a series of holes right along the little line that I scribed. And as soon as I get that drilled all the way through, then all I've got to do is take a saber saw and very, very quickly just cut the end off, and that will give us the rounded corners. So what we do is we put it in, line up this with the as close to the previous hole as possible, get the hole started, and drill down through. Okay, as you can see, I've made this plate, cut off the corners. We cut them off with a milling machine just by cutting the edges. Now we've got to true it up and make this thing round. To do that, we're mounting the center hole onto the lathe over here, and we're going to continue to turn it and cut this down until these are nice and smooth and it's all the same center out. This is going to take several hours. So rather than waste a whole lot of tape and battery and stuff and put you guys to sleep, I'll just shut this video off and I'll turn it back on as soon as I get it to the point where I'm happy with it. But at least you get to see exactly what I'm doing. You can probably see the center hole looks like it's wobbling a little bit, and that's okay too, because once we get done here, we're going to be cutting that plate to make this back piece, and this will be perfectly round. And then when we turn it over, that hole will be made round from this side. So all will be well. Okay, we've turned this on the lathe, and you can see now I've got a nice polished corner all the way around. There is a little bit of a ding here where the bit got in a little too deep, and this one here is a little skived. But you know, I'm not really worried about those right there. That's going to be on the inside cup anyway. So now this is ready to start turning. It doesn't really look too bad. It looks like it's cutting a little bit more on the outside than the inside here, but here it's perfectly square. So I'm not exactly sure why it's giving me that. That looks square. That looks square. So I'm thinking that this particular spot right here might have a little bit different bevel to it where it was cut, because these weren't exactly 100% machined. Now this side over here is the one that's going to go up against the block of the engine. This side over here is the one that's going to have the tubes on it to extend it out. So this side needs to be faced so when it's bolted onto the engine, it won't crack from tightening these bolt holes here. These deep ones are going to be on that. So you can see how I'm increasing the size of that plate considerably. It doesn't need to be that thick because it only needs to come out to here. So we're doing away with some of this. Next thing I got to do is surface the front of this and then cut this deep bevel on this side, and that's going to be the next part that I have to do. I have to cut it in that deep and that much for the bearing. As you can see, there's a double lip there. This is for the actual casting of the engine, and this is for the bearing where it sticks out just a little bit. Then on this side, the seal goes into. Alright, so we're calling it quits for today, and I'll bring it back when we get ready to start doing the facing on this. Okay, we've actually run a surface on this. to get it evened up and nice and smooth. It's still kind of a rough. We're going to make a finish pass as we go over it. But right now we're starting to cut out the center hole, and we're getting this has been mic'd out to very, very close to what we want to get this hole in there. So you can see we've started, but we've got a long ways to go. This could be a long process. Where right now this is not the full width. Once I get this down to the depth that I need, then we'll do this finish diameter of the hole, and then we got to do the recess that you see here. So we are in the process, and I'll give you one pass on the lathe here with the camera, so you can get an idea of what it looks like when she's shaving it off here. We only do 2,000ths at a time. You remember, this is a mini lathe, it's not a big one. So it's going to be a long process getting this bored out to where we want it. One more pass. 2 more thousand. This poor little mini lathe, if you try to take too much of a bite, okay, we've been making this cut to make this shelf as deep as the original, and we're about halfway there. You can see how far in it's gone. It's going to be still a long process, but I'll give you a few more passes of what I've been doing. And we'll bring the video back up as soon as we get the depth to where we want. We've got the micrometer set for our depth that we need. Get the video camera over here so we can see how much more we got to do to get it to that point. And here's the original one. The original one is right here, and as we can see, that's full depth. So that's what we're setting right now, and then we've got to do the added little shelf that's up in here. Okay, we have now come to a tricky part in our project. This is the back plate that goes on the gearbox. You'll notice that the drum has a little bit of a taper to it where it comes off from the box. So we have 3/8 of an inch that we can go in here. This is very tricky because we got to get by these teeth with these cutting blades. We don't have much to hold this dead center except for this little lip inside of here. We have to cut the taper for this drum to be able to go bolt up against the box. It's going to be inside slightly. The taper has to come all the way out to this lip. We've already marked it way out here. So we have to keep cutting this taper. We've set up the lathe with the taper that we need for it to match. We have to keep cutting this from, you can see a little bit of a line down in here is the depth that I've got cut. Now I have to cut it that way at that level until this taper reaches this point right here. Then we can drill the plate and we can set it onto the gearbox, mount it, and then we can mount the drum into the receiver on the gearbox, and then this part will be done. Then we have to make the spacers to go from here to the other plate. Now, what I've done over here, I used an exhaust pipe expander to try to find center between these two plates. And the reason that I'm doing that is this has to have an oil seal in it, each one of them. This is the replacement, this is the original. The oil seal has been cut to fit. I overcut it just a tiny bit, so you'd think you'd ruin the plate. Well, you haven't ruined the plate. I just have to get a slightly bigger diameter seal. The original 47 millimeter, and the replacement one will be 48 millimeter, and that'll make up the difference for what I cut. And it's still the same type of seal, so that's not going to be an issue. One good thing about seals is if you mess up on a seal point, you can always cut it a little bit bigger and put a bigger seal in. As long as the shaft diameter size where it actually seals, that's your criteria. So what I've done to center these, to get ready to pilot these holes, is to make sure that both center holes where the shaft comes out, that's critical. Everything else is irrelevant. As long as when it bolts on, the shaft is dead center. So I've marked these holes with a marker down inside, put it together with this expander, which should hold the center hole from this one to the center hole of this one. And then what we're going to do is we're going to put a guide down inside of here. We're going to pilot the holes through until we get them to the size that the original bolts that go into this will actually hold this box or this plate to the engine. And this one over here, once we get this one done, the bolt holes are exactly the same because they mount up with these. So this acts as our template for this plate, this for this plate. So we're going to do the same thing. We'll have to be able to put this onto here when we find dead center. We'll have to pilot these holes so that when we put the bolts into the gearbox will mount to this on this side based on these holes right here. So we'll keep you updated. This is going to take several hours to get this recess and this taper to the point where this will actually sit inside of that enough to be able to bolt to the coupler inside the gearbox, be able to clear the plate. Then this will be sticking out. It'll actually be flush with here with enough airspace so they still get some cooling in there. And then that will allow us to have out here bolt holes for our expansion pieces to go in here to make this plate bolt to this plate. Okay, we've turned the plate. We've got the bevel for the drum to sit into. Let me see if I can set the camera here for you. Good. Yeah, that should do it. Okay. Here's the bevel for the drum, and that will let that recess right in there. Now this plate has to mount to the gearbox. We've got the center hole, so that it goes on just like that. Fits right on over this little recess in the case. Next thing I did was put the plate on, come through the back side here with a marker, and mark the center of the hole. On the drill press, I'm drilling out these two holes. Now, we can't get in to mark these, so what we're going to do is we're going to drill these, tap them. We're going to turn this upside down, and we're going to bolt it into place down here. And then, with it bolted into place, we'll mark these two holes, so that they'll line up with the existing gearbox as if it was bolting right directly onto this block. And then we've got to do the same thing with the mounting plate over here. Okay, here's the spare engine, which just gives us the mounting plate to go onto here. See the recess that we did in the other plate goes right on over this thing. You see there's a seal in the back of this engine. This engine has a seal in it, but the one on the airplane does not. so we have to rely on the seal that's going into just the plate that's going on here, because they changed for some reason during construction. This is a newer block than the other one. They incorporated the seal here, so they didn't need it in the plate out here. So we're just going to go with what we've got for now. If we have to, we can always change the bases. Take the crank out, change everything over, and just use this base where it repositions that bearing a little bit. The other one, the bearing, actually you can see the whole bearing from the end, right where the gearbox bolts on. So now, we're in the process of drilling out these two holes here. We're going to tap them, and then we're going to bolt it on, mark these, and then re-drill those. Okay, we've got it. We've got the bevel done. We've got the holes all drilled. I'm going to mount this plate now onto the gearbox. We've got to get the bolt started and get it on. And then we have to mount the drum to make sure the drum is going to turn and clear around the whole inside of this. So what I'm going to do now is I'll bolt this on, torque it up, we'll put the drum on, and then I'll bring you back. Okay, we've got the plate all marked and on. We've got the drum that we're going to be putting on. We've got marks to keep it lined up. We've got a line here and here. Now we need to tighten this up and make sure it's not going to drag on the inside of this. And then we have to take it all back apart when we get all done and make sure that we Loctite all the thread lock on every bolt. Right now we might have to put it together 15 or 20 times before we get the machining completely done. Now we need to torque this up. Three. And there's 4. Alright, keep your fingers crossed. Finished product. All we gotta do is put a seal in there, and this piece is done. Okay, this next step in the project, we have a round aluminum dowel, and I am precision cutting these spacers that are going to go in between the two boxes. What we're going to do is we're going to take these spacers, we're going to drill them. They're going to sit in between the two plates where the disc goes in, and we're going to screw a screw in from here, screw a screw in from here through the plates, and then we're going to mount bolts as well. But these are going to be what's spacing them out. So what I do is I bought a piece of 3/4 inch rod, and I've taken the rod and I'm cutting these off exactly with a cutoff tool. It's a long process, but when they come out, they should be exactly the same thickness, every one of them. We've had to hand file a little bit just to make sure that they're all exactly where they're supposed to be, because we don't want this plate to be these plates to be warped in any way from torque and putting any undue pressure on them. Even though they're 3/4 inch thick, we don't want to put any stress cracks in it. So this is the process that we're doing now. This is very loud, it's very distracting. We have a little bit of a cutoff tool right here. Cutoff tool cuts into the rod as we're turning. We have to do this very slow and very methodical. Can't just cut it in because this is very hard aluminum and it starts to radiate. The shaft will start to vibrate. It should start to chatter. We do use oil, but the oil is very short-lived on this. plug gets extremely hot. The high-speed steel bit down here gets very hot, and when that happens, it starts to chatter. So we cut one, we cut it off, we measure it, give it a chance to cool down, and then we'll come back and we'll cut another one. I want 8 of these in total. So right now I've got 3, 4, 5, 6, 7. So this is the last one that we're cutting off, and we should be good to go. Okay, we have cut off these spacer dowels. I'll try to get you up just a little bit more here. We've got these spacer dowels now, and these are going to actually have to be drilled through and tapped, because we need to put screws into the base of each plate into this spacer. So now we need to get this set back up. We're going to change this. We're going to put in, okay, now we have the drill chuck. The drill chuck is going to go in here. On this particular project, we're going to use an 8mm by 1.25 thread to put each plate. The plate will be here. We'll drill the hole, countersink the head, drill into this. So we can mount each one of the plates using these. We're going to have 8 of them, 2 on each corner, and then we're going to have 4 bolts holding the whole complete unit together on top of that. So we should have enough bolts holding it together to take up any fatigue or stress. So the next project here now is to get the right size drill. We're going to go to our drill guide. We're going to find the right size drill for the right size tap to do an 8mm by 1.25 thread for our bolts. So the next process now is to get the right drill thread by 1.25. For an 8mm 1.25, we need a 17/64 drill. We're going to be now turning. We want to slow this down, and we're going to actually be drilling the hole all the way through. We need to make sure we're absolutely dead center. What we're going to do is just start, just to make sure that we're hitting in the middle, and it does look like we're dead center. Alright, so now what we're going to do is we're going to take a little tiny drill, and we're going to start piloting the hole all the way through each one of these. Then we're going to step up to the 17/64. Then we have to run an 8mm 1.25 thread through this whole thing. So we're going to do the thread all. Okay, we've got our small pilot drill, and what we're going to have to do is take it through in steps. We go in a little bit, back it out, go in a little bit, back it out, all the way through. But this doesn't have enough cranking to go the whole distance. So we have to take it in through as far as it'll go, back it out, reset the drill a little bit further, and go all the way through. Now we want to go all the way through. We have found the first one that we did is right here. We actually have the hole perfectly dead centered, and it came through perfectly dead centered. So we've got the jig set up right. Everything seems to be tracking really good. So we're going to do all 8 of these. When we get done with all 8 of these, then we're going to increase the drill size to the 17. Okay, so now we're going to start doing this pilot hole. You can see this is going to take a while. Okay. In order to get our tapping, we've got our pilot holes all drilled. We've got a tap here. We're going to use the tailstock in order to get this lined up perfectly so that it doesn't start in kitty-cornered. So we're holding this in the vise. In the jaw chuck. So what we're going to do, let me put the camera over here. see if I can give you a good view of what I'm doing here. This is only to start the holes. Oh, that's a good. This is to get the holes started. So what we do is we just bring this up close enough so that we can start this in and keep it straight. We're going to turn this by hand. We're going to get just 2 or 3 threads started in this way. That's good right there. That'll give us a start. We back this back off. Take this out. We're going to turn it around. And we're going to do the same thing. We get it started. Tailstock acts as a guide just to keep it so that it's actually piloting straight. All we got to do is get them started. Then we can hold this in the vise and actually use the holding tool to thread it in. Alright, so now we've got them piloted, we've got them started. So what we've done was taken this tap, we've converted it now so that we've got it back in its original hold. We're going to put the cutting oil on, get this in. I've actually marked with paint. I don't know if you can see this or not, but I've marked with paint the depth that we need to go. As long as I can see clear thread, I know we're not deep enough. So the reason that I'm holding it in the vise and with the vise grips is I don't want either one to spin and mar up the aluminum bushing. This stuff. The first tap that I had, I couldn't even turn it by hand. It was ridiculous. But this one, this double fluted tap, really cuts it in good. Seems to go through almost like butter. Out. I'm kind of shaking the whole bench here. This bench isn't much to speak of. I had to give up a really good shop in Maine, and now I have to settle for this little bitsy shop down here in my garage that's so full of junk that I can't even hardly move in it. Cutting oil is more like a gel, but it works really nice. A lot better than that 3-in-1 oil. So from now on the lathe, we're going to be using this special cutting oil. I think it'll do a much better job. My shoulder and my back, this is kind of testing me here. And another thing that I like to do to test it for depth is to take one of the screws that we've got that we're going to actually be holding this together with, and I chose to go with an 8mm thread, 1.25 pitch, and after it's all the way in from the round bushing to the top of this bolt should be 3/4 of an inch, which is the thickness of the plate. And we have 7/8, so we're not quite in far enough yet. Just a little bit more. We don't want to overcut because the two will merge together in the middle. There should be 1/8 of an inch between the two once they're there, so they don't come colliding together. Also, we don't want to have any thread debris packing up between the two nuts either. So we need to make sure that when we get all this done, we're going to actually wash these or clean them out. Make sure that there's absolutely no debris in there. the black paint. So that should be it. The way that first tap was working, I thought it would take a month to get this done. I couldn't even turn it by hand. I had to put vice grips on it, and I can only go a little tiny bit at a time. That's the difference between American made and Chinese. Can't beat a quality tool. Okay. Check for depth. Breathe there. Nice tight thread, I like that. No slop to it at all. And 3/4 of an inch. That one's perfect. Now we're not going to leave it in there because as we cut the other side, it's going to drop the cuttings down through the hole, and we don't want to pack them in between. So now we just flip it over. And we do the other side. Cut the little start our cut. Remember, we piloted these so they'd go straight. That way they're not going to go in at an angle and bind up halfway through. They are actually perfectly square. Now, let's take this one. It's tight right there. Tight right there. We are below 3/4. Below 3/4, so perfect. They're actually butted right up against each other at that point. So now we're going to do this to all 8 of these, and then we'll pull the plates back apart and put the plates together. Okay, now what we've done, we've taken both of these plates back off from here, and what we've done is gone around and we've marked and measured every hole for each one of these stanchions to go onto. This one's going to be a center hole to mount to the other plate. These little divots right here are all pre-measured exactly far enough apart for these to go in. These holes will be right there. Now we're going to have to recess these holes on this side for the heads to go into, so they'll come out flush, and still be enough so that these on this side, the drum will clear here. You can see it's off from center out to here like this, and the center holes are the mountings. This one, this one, this one, and this one for mounting the longer bolts, which are these, to connect the 2 plates together. So now we're going to drill out every one of these holes that we've marked. This is just a pilot hole. Then we have to drill out each one with this. This one is going to be for the 8mm bolts. This one is going to be for the 10mm bolts. This plate here is going to have to be threaded here, here, and here, and here. But to do that, first we have to pilot these holes, then line this thing up where it's going to be. We have to measure out from center, again, to make sure that we get the holes exactly where they're supposed to be. We'll drill these to match these, and then we'll put pins in to line them up, and then we'll have everything centered to center. Okay. Now what we've done, we've got both plates back off. I've got the original plate in the middle. I've got the engine plate with this plate hooked onto it as if it's the same thing, the same bolts holding it on. I've got the clutch plate going in as if it's bolting to this. So this is actually simulating both plates. So now that those are sandwiched together like this, I'll be able to pilot down through all of these holes, and they'll line up exactly with the other plate. Then, after I pilot those and get them lined up so that we get the mounting bolts along with the spacer bolts going to go here like this. It's going to be 8 of them going all the way around. And then the mounting bolts are going to be going through here, and they're going to be threaded into this one, so they'll actually pull together. And the plate going in between here, see, it'll actually be further apart for the disc, for the drum disc to go in there. So now what we need to do is pilot these holes, take it back apart, put this one against this one, and bolt them together. Once we do that, then we can actually drill, put this back on the lathe, turn both pieces to be exactly the same shape, take out all the imperfections, and they'll look like they were actually machined together. Then we will reassemble everything, put it all back together, see how it lines up to make sure that we have everything center to center. It looks pretty good. It would only have to be off a couple of thousandths to really mess us up. So we're just going to hope that this is going to actually center everything the way we need it centered.